Okay, so hello everyone. So our today's topic will be graphically linear equation inequalities. Okay, graphically linear inequalities. Okay, so let's actually talking about some of the really important information first. Okay, so here what we have is the here is the definition of the linear inequality in two variable. Okay, so let me actually read the definition first, and then give you some example. So the definition, inequality can be written in the form this. Okay, so inequality that can be written in the form ax plus by less than z. Okay, in which a and b are not both zero. So a and b are not both zero. So that's the condition. So keep in mind with this equation. Okay, so keep in mind. Okay. Make sure you keep in mind in this equation. All right. And so right now the example what I want to give you guys is the inequality symbol. Okay. So the inequality symbol is something like this. Okay. This is I think this is an inequality symbol. Inequality symbol. Okay, so let me actually give you guys more example. Okay, let me actually zoom in a little bit. Okay, so there are basically four simple. You need to know it for the four inequality symbol. Okay, there are basically four. We have in a lesson, and then we have in a lesson equal to, and then we have bigger. Let me actually write a little bit more clear. Okay, so what we have here another bigger, and then bigger and equal to. Okay, so those are the four simple. Those are the four inequality symbol. Okay, so those four inequality symbol can basically basically all of it can be applied to the equation of the inequality. Okay, so here let me actually write it down the meaning of those symbol. Right, the meaning of this symbol. This one represent less than. Okay, this represent less than. Let me write it a little bit more clear, I guess. This represent less than. Okay, this one represent less than equal to, and this one represent bigger than. Sorry for the writing, and then this one represent bigger than equal to. Bigger than equal to. Okay, so keep in mind with those simple. Okay, so keep in mind with those simple, because okay, so keep in mind, so those are all the simple for the inequality, inequality symbol. Okay, so the second really important thing what I want to tell you guys is actually this part. Okay, it's actually the part over here. It's having a lot of words, I know, but I will really explain and then make sure you guys does understand it. Okay, so that's a lot of equation. So here let me actually show a little bit better. Okay, I think this is the best I can show. Here what we have been talking about is how we actually graphic a linear inequality. So that's basically the topic for this section. Okay, so is how to graphic a linear inequalities. Okay, so let me actually move into this part. Okay, let me actually move into this part. So first of all, I basically want to explain a little bit about this part. Okay, let's first actually read it, and then I will explain how you actually graphic a linear inequalities. Okay, so we got totally 3 steps. The first step is we have to replace. We have to replace the inequality symbol with an equal sign. Okay, we want to replace the inequality symbol with an equal sign to form the equation of the bounded line. Okay, to actually form the equation of the bounded line of the graphic. Okay, and now let's actually move into step 2. Step 2, what it say is like we have to graphic the bounded line. Okay, we have to graphic and bounded line. We actually going to using a dotted line. The dotted line if inequality is not included. Okay, so wherever you see bigger than, wherever you see less than or bigger than, then we have to draw a dotted line because inequality is not simple. Inequality is not included. Okay, and you have to using a solid line. A solid line if inequality is included. So whenever you see the symbol less than equal to and bigger equal to. Okay, because over here is that you see we have less than equal to means it is included. The point is included, so you have to using a solid line. Makes sense, right? Okay, so let me actually talking about this again. So here, if you seeing the circles, if you seeing the symbol bigger and equal to means the point is included, so you have to using a solid line. Okay, so let's move into step 3. Okay, let's move into step 3. Step 3 is basically saying you have to you're gonna choosing any convenient test point. Okay, you're gonna choosing some point. Okay, and that point have to be not on the line. Okay, not on the bounded line. So you can choose any point, as long as it is not on the line. So okay, that's it, as long as that's not on the line. And here is say, so here, if the inequality is true at that checkpoint, at that point, the point you choose it, then you basically shaded the half plane including the test point. Okay, so that's the meaning of it. If you basically checking, if you checking the inequality is true, okay, is true on that checkpoint, then you basically shaded the half plane including that checkpoint. Okay, otherwise you shaded the other half. You shaded the half plane not including the checkpoint. Okay, not including the checkpoint. So that's basically all the words. Let me actually doing some so that's basically all the words. I know that's basically all the words of it. Okay, so let me actually show you guys how we can drawing a graphic by using those steps. Okay, so the best way to actually demonstrate how to draw it is basically show you guys a real example. Okay, so let's right away drop into the first problem. Okay, here we want to graphic each inequalities. Okay, so let's moving straight into it. I will show you guys how you can actually apply this method. Okay, so if you are not sure, if you kind of not sure, then make sure you go back, or maybe even write it down all the steps in your notebook. Okay, that will help you to actually understand it. Okay, so as we mentioned before, here we are going to using exactly the step. Okay, I was using exactly the step the step which I tell you guys before, and we will use exactly in the step over here. The step 1 is saying we have to replace the inequalities to the equal sign, right? That's basically what the step 1 say. We have to replace the inequality. The inequality over here is bigger than, so we have to replace it with equal to, sorry, it's actually equal to 12. That's my mistake. Sorry about that. Okay. So basically, we have already replaced it, right? So the next thing is we want to find the bounded line, right? So the next thing is we have to find the bounded line. So how you actually find bounded line is basically you have to draw the graphic. Okay, here the second thing is want to find the bounded line. Let me actually write it down. Okay, the bounded. How you actually find the bounded line is you basically you trying to graphic this equation. Okay, so that's you trying to graphic this information. So how you actually graphic the information is you need to find the x-intercept. Okay, you need to find the x-intercept. That's the easiest way. So as in the previous video, right? So if you're not sure, please take a look about my previous video. Okay, so cause everyone knows that the x-intercept and the y-intercept are the most easy point you can find, right? The most easy point you can find, right? So, and everyone know if we want to actually graphic a line, cause this one is actually a line, right? Because it is a linear equation, so you need to have minimum, you need to have 2 points to actually graphic, right? So the x-intercept is basically, let me take a look, it's actually 3, 0. Okay, the y-intercept, let me take a look, y-intercept is basically 0, 4. Okay, and let me take again, x-intercept, yes, x-intercept is 3, 0, and then y-intercept is 0, 4. Yeah, okay. So now you want to plug in those points. You plug in those points, right? So now we are actually moving to the second step. Okay, the second step is saying we have to graphic the bounded line, right? So we have to graphic the bounded line, right? And you can see over here is bigger than. Bigger than means it's gonna be a dashed line, right? It's gonna be a dashed line, not included, right? Everyone keep in mind, right? So here what we have is bigger than. So bigger than means we have to draw a dash line, like a dash line, cause the point is not included, right? The point is actually not included, right? So the first thing we have to put in the x-intercept and the y-intercept on the graphic. Okay, x-intercept is 3, 0. So let me actually label it. X-intercept is over here, 3, 0, right? The y-intercept is 0, 4. So let me actually label it 1, 2, 3, 4. So label over here, this is the y-intercept. Okay, so now we have to draw a dash line. A dash line is something like this. Okay, it doesn't have to be really exact. I mean, it doesn't have to be perfectly fitted. Okay, it doesn't have to be like that. So, but okay, let me try my best to actually draw the best line. Okay, so you're drawing something like this. Okay, so now we have already complete the second step. We have already completed, right? So let's actually talking about a little bit detail. Let me actually repeat it again. Okay, the reason why we have to draw in the dash line is the symbol over here is bigger than. Bigger than means the point is not included, right? Bigger than is this point is not included, so that's why we're drawing a dash line. Okay, you guys get it, right? Okay, so now the step 3 Step 3 is basically we have to find the region, right, for the equality. So step 3, let me actually repeat again. Okay, so step 3, more specifically, is we need to find any checkpoint, right? Any checkpoint. Okay. So let me actually make things. Let me actually, first of all, let's actually let's find a checkpoint first. So the checkpoint which I'm going to using over here is actually 0 and 0. Okay, the checkpoint what I'm going to using over here is 0 and 0. Okay, and so basically the thing over here, the trick over here is you have to plug in this checkpoint into the inequalities. Okay, you have to plug in into the inequality. So what we have is 4 multiplied by 0, and then plus 3 multiplied by 0. No. And basically 3 multiplied by 0 is bigger than 12. So now that's that. So now you can see over here 4 multiplied by 0 is actually 0. So and then plus 3 multiplied by 0 is also 0. So as you can see, 0 is actually not bigger than 12. So that means that basically means the statement is false. Okay, that basically means let me actually move a little bit. The statement is false. Okay, so that basically means the statement is false. Okay, so basically since the statement is false, so that means we have to shade it. We have to shade it the other half panel, not including the 0 point, right? Not including the point 0, 0, right? So that means you have to shade it this part. Okay, so that basically means you have to shade it this part. Okay, so that's basically all the steps, I think. Okay, so you have to basically shade it all the parts over here. Okay, something like this. Okay, so that's basically the meaning. Okay, so the bounded line that's basically so you are actually using the bounded line as the indicator. You neither shaded the right of the bounded line, the right of the bounded line, or the left of the bounded line. Since over here 0 and 0, the statement for 0, 0 is false. So you are not going to shade the left side of the bounded line, because that part, the statement is false. So that means that point is actually not in the inequalities. That is actually not in the inequalities. So you have to shade it the bounded line not including that point, which means you have to shade the bounded line of the bounded line to the left, to the right half panel. Okay, so that's basically the meaning. Okay, I think it is really well explained, right? Okay, so now if you still don't understand, then I still got like 2 questions. Okay, I still have 2 questions over here. Okay, let me actually show the question first. Okay, so here we have only 2 questions left. Okay, question 2 and the question 3. That's That's basically it is. Okay, so let's actually do the question 2 together. Okay, so let's actually do the question 2 together. So question 2 over here, what you can see is so let's right away go to the steps. Okay, that's step 1 is you have to replace the inequality with the equal sign, right? I'm making a mistake over here. Negative 2x minus 3, right? Okay, y equal to negative 2x minus 3, and then after that you want to find the bounded line. Okay, you want to find the bounded line. How you find the bounded line is you basically find the x-intercept and the y-intercept. Okay, that's basically the steps. X-intercept, you having it for x-intercept, you're letting y equal to 0. Okay, for x-intercept, you're letting y equal to 0. So let me actually calculate a little bit. Equal to 0, negative 2x equal to 3. X is basically x equal to negative 1.5. Okay, let me check again. Yes, x equal to negative 1.5. Okay, y-intercept, you just basically letting x equal to 0, and then it's negative 3. Okay, y-intercept x equal to 0, negative 3. Okay, so now we move into the step 2. Step 2 is you have to graphic the bounded line. Okay, let me actually rewrite this part. It's kind of like a little bit mess. Graphic the bounded line. So as I tell you guys before, how you graphic the bounded line is you basically graphic okay, so here we want to graphic the bounded line. The bounded line, you just basically put the point of the x-intercept and y-intercept on the graphic first. And over here you can see this one is lesser, so that means we have to using a dash line. Okay, so we have to using a dashes line, right? So it's lesser, so the point is not included. Okay, so the point is actually not included. Let me actually write a little bit better. The point is not included, so you have to use a dash line. Okay. Let me actually put in the points. Let me actually label it. We have a 0 over here, and then what we have is negative 1, and then negative 2. So negative 1.5 is over here. Okay, in the middle of it. It doesn't have to be really exact. As long as you put it in the middle, it's gonna be fine. Okay. Negative 1, negative 2. Okay, we did it right. And then we having y-intercept is 0 and negative 3. So we have negative 0, 1, negative 2, and then negative 3. So negative 3 is over here. Okay, so the y-intercept is 0 and negative 3, right? Negative 3, so it's right over here. So now we have to join a dash line. Okay, it doesn't have to be perfectly, but you have to try your best. Okay, like this one is kind of like a little bit worse, I feel like. Try your best. Okay, so try your best. You don't just try a little bit more. Okay, and so now we have finished the second step, right? So now we have finished the second step, and then let's move into the third step. So step 3 is not find, just choose any checkpoint. Choose any checkpoint. Okay, so the checkpoint over here, what we're gonna choose is 0 and 0. Okay, so remember 0 and 0, the original 0 is always a good choice. Okay, choosing 0 0 is always a good choice. All right. Okay, it's a good choice for a checkpoint. Okay, so as I mentioned before, so right now we have to check in the statement. Okay, So right now we have to check in the statement. If the if the statement is true, then you shaded the area, including that checkpoint. If not, then you shaded the area. So let me actually repeat again. Okay, so if the statement of the checkpoint is true, so you shaded the area respect to the boundary line to the side, including that checkpoint. Okay, if the statement is false, then you respect to the boundary line, shaded the area not including that point. Okay, so here, how you basically checking the statement is basically plugging the point into the inequalities. Okay, that's basically the thing. Okay, so let's actually do it. So y equal to 0. 0 is less than equal to negative 2x. Negative 2x multiplied by 0 is 0. So 0 minus 3 is 0, is negative 3. Okay, so let's check in the statement. 0, negative 3. So as you can see, the statement is false. Okay, so 0 less than negative less. So everyone understands it, right? So 0. The statement over here is false. Okay. Let me check in again. Okay. Let me actually write it down. Something over here. The statement is false. The statement is false over here. Okay, the statement is false over here. That means not including the checkpoint. Not including the checkpoint. Okay, so that's basically the thing over here. Okay, so let me actually write it a little bit more. Okay, I think let me actually write down a little bit more. Let me actually write a little more. 0 and 0, not including the checkpoint. Respect to the bounded line. Back to the bounded line. Okay. Okay. So now let's actually finish the graphic. Okay. So 0. So as I say over here, so this is the 0, 0. The original is not included, so we have to shade it the other, the part with respect to the bounded line, not including the size with the 0, 0. Okay, so you shade it something like this is good enough. Okay, so everyone understand it, right? I should try to show everything. Okay, everyone understand it, right? So here 0 and 0 is not included with respect to the bounded line. So you shaded the other half not including 0, 0. So you shaded the left half panel, right? The left half panel of the bounded line. Okay. Okay, so let's move into the last question. So the last question is, since this one is actually the last question, then pause the video and you're trying to do this question by yourself. Okay, pause the video. Okay, now let's actually do the question together. All right. First of all, you can see this this equation is actually not in the simplest form, right? This equation actually is not in the simplest form. So the first thing is you have to simplify it. 2x plus 2y minus x is bigger than 6. 2x minus x is x plus 2y is bigger than 6. So this is the simplest form, right? Okay, so we are actually using this. We are actually going to using this form to graphic our inequalities. Okay, so we are actually using this form to graphic our inequalities. Okay. Okay, so the first step, as we have been done many times, right? The first step, step 1, is basically you have to you let me record it. I think is yeah, you have to let me think about it. The first step, what we have to do is we need to change the inequalities to the equal sign, right? So that's basically our first step. Changing the inequalities over here is bigger than to equal, right? And the second step is if you want to find the bounded line. Okay, the boundary line. How you find the boundary line is basically you try to find the x-intercept and the y-intercept. Okay, how you find the y-x-intercept? You just basically make x equal to 0, and then this one is 6. How you find the y-intercept? You guys are basically setting x equal to 0, and then y is equal to 3, right? Okay. Yes. And now we are ready for the second step, right? The second step is we want to graphic the bounded line. Okay, so we want to graphic the bounded line. So here, you can see over here is that we have a bigger than means dash line. We have to draw a dash line cause the point is not included. Okay, so here it's bigger than, so that means we have to draw a dash line because the point is not included. Okay, so now what we have to do is we have to put the x-intercept and the y-intercept on the graphic. Okay, so let me actually label it. X-intercept is 1. No. Let me actually erase this part. Okay, so let me actually label it. 1, 2, 3, 4, 5, 6. Right, 1, 2, 3, 4, 5, 6. X-intercept is 6, 0. So you putting the points over here. You're putting the x-intercept over here, right? Y-intercept is 0, 3, so it's 1, 2, 3. Y-intercept is 0, 3. Okay, so 0, 3 over here, right? So 0, 3 over here. Let me check again. Yeah. Okay. So now we going to draw a dash line, right? We are going to draw a dash line. Okay. So let me try my best. Okay, I think it's fine. Yeah, I think it's totally fine. As I say, it doesn't have to be really exact. Okay, it doesn't have to be a perfect line. Okay, so now we finished the step 2. We finished step 2, and then let's move into step 3. Okay, step 3. Step 3 is we have to choose any checkpoint. Okay, so as I tell you guys before, 0 and 0 is always a good choice for the checkpoint, right? And as I tell you guys, how so now we want to checking this checkpoint we want to check this, the statement of this checkpoint is true or false, right? So what you have to do is just basically plugging into the original, the equation, okay? The equation what we have to plug in over here, let me actually write it down over here. Equation is x plus 2y bigger than 6. Okay, let me check again. X plus 2y bigger than 6. Yeah, so that's plugging. Okay, plugging is basically 0 plus 0 plus 2 multiplied by 0 is bigger than 6. 0 as 2 multiplied by 0, 0 bigger than 6. So you can see the statement is false, right? So statement is false. Let me actually write this 0 a little bit better. Okay. Zoom in a little bit to show you guys much a better way. Oh no, just look at the 6. Okay, let me check again. Yeah, so here you can see the statement is actually false, right? The statement is actually false. Oh, okay, so let me check again. So here the statement is false. Okay, the statement is actually false. So since the statement is false, you know that not included. Not included respect to the bounded line. Okay. Okay, so here you can see the statement is false. Since the statement is false, then we are actually not including the checkpoint with respect to the bounded line. Okay. Okay, so let's actually, so you can see the point over here, the point over here, this is the original point, right? So this is the original. Okay, so here it is not included, so you have to including the other half of the panel. Okay, so basically including the other half of the panel. Okay, something like this. Okay, it's good enough. Okay, so here you can see over here is that you can see, like, you know, the point is actually not the point 0 0 is the statement for 0 0 is false. So that means we just cannot include the half plane. We just cannot including the half plane which have 0 0. So we have to include the other half plane. Not including 0 0. Okay. Okay. So yeah, let me actually take a look again. Okay. Let me take a look. Okay. Let me actually take a look about this point. Okay, yeah, so now we have already solving this problem. Okay, so that's basically all the steps, you know, that's basically all the steps, you know, how you actually graphic inequality. Okay, this section is quite small. Okay, so hopefully, you know, hopefully everyone, you know, just get the right answer for this question. Okay. Yeah, so let me actually moving up a little bit. Okay, so in this section, you know, we're basically talking about so the definition of the linear inequality in two variables, right? Okay, and after that we have been basically talking about the how you actually graphic a linear inequality by applying those three steps, right? So I think over here, we have 3 examples over here. I fully show you guys, how you actually, you know, how you actually figure out, how you actually using exactly those 3 steps, how you actually apply it, right? Okay. So basically, thank you guys to actually watching this video. Excuse me. Okay, excuse me. Okay, so I basically tell you. So basically, thank you guys to actually. Okay, let me. I repeat again. Sorry. So thank you guys. Anyway, thank you guys. Okay, to watching this video. Okay, so if you still having some problem, I mean, if you still kind of like confused, then maybe go back and then thinking about it. Okay. Or you can also leave a comment below. You can ask me maybe specifically why. What maybe you kind of like confused why it's like that. Then you can ask specific question on the comment section. Okay, on the comment section. So otherwise, make sure you actually subscribe to my channel. Okay, make sure you actually subscribe to my channel, like the video, leave a comment if you have any question, and also turn the notification button on. I will keep uploading videos. Okay. Otherwise, see you guys. Otherwise, hopefully you guys does learn something from this video. Okay. Yeah. Good luck, and then see you guys in the next video. Okay.